In this tutorial, we'll be going over infrastructure as code using Terraform. The virtual server we deploy with Terraform will be used later to deploy a working Minecraft server. To make sure we're on the same page before diving into the topic of Terraform, we will go over just a bit of the basics behind some of the important concepts. First, we will cover version control with GitHub. GitHub is a cloud-based service where developers can store, manage, and track code changes to their projects using Git. This is where the deployment code will be stored. Then we will briefly discuss cloud providers. A cloud provider is a company that offers computing resources over the internet. These resources include services such as physical and virtual machines, storage, and virtual networks. We will be ordering a virtual machine from a cloud provider. Next, we will finally start talking about Terraform. Terraform is an infrastructure as code tool used to build, change, and version control resources. Terraform works with both cloud and local resources. We will be using the concepts covered here to order the virtual machine. The last topic we will cover is Terraform code. Here we will go over the code I use to deploy a virtual server on Vultr's public cloud, and then we will use the Terraform code to deploy a server. GitHub provides a place for developers to store and track their code changes. The GitHub concepts that are important for this tutorial are repositories and pull requests. First off, a repository is a place where code is stored on GitHub. You can think of a repository like a directory on your computer. Many popular applications or websites have their code tracked on GitHub. A few examples are FreeCodeCamp, a website dedicated to providing free resources for people wanting to become software engineers; Chromium, the open source web backend for both Chrome and Edge browsers; and VS Code, a popular IDE used by many developers and provided completely free by Microsoft. Next, a pull request is a way for a developer to submit their code for review before it is added to the main branch of a Git repository. Pull requests help keep code changes organized. Typically, a developer will create their own copy of the code base. This is called a branch. They will make their changes to their development branch, and then they will create a pull request to get their development branch merged into the main branch. The image on the right-hand side of the screen shows some examples of pull requests that are currently opened against the VS Code codebase. The Terraform code created for your infrastructure should be stored in a Git repository and version controlled using a service like GitHub. A cloud provider is a company that offers computing resources over the internet. These resources include services such as physical and virtual machines, storage, and virtual networks. AWS, Azure, and Google Cloud are all examples of hyperscaler clouds. They are considered the big three of cloud providers, and they get the name hyperscaler based on the sheer volume of infrastructure they have running in their clouds. Alternative cloud providers also exist, which many times will offer better pricing and better customer service than a hyperscaler. Some examples of alternative cloud providers are DigitalOcean, Linode, and Vultr. When choosing a cloud provider for a project like a Minecraft server, some things you will want to consider are cost, reliability, and support. Cost matters because computing resources can be expensive, and often the cheapest options aren't the best, but that doesn't mean the most expensive options are the best either. We want a server to have fun playing a game with our friends that won't break the bank. Reliability matters because you want your game server to have the maximum uptime possible. Having to deal with customer support about server issues instead of playing your game would be no fun. Support matters because in the event something does happen, you want to know someone will have your back to get you back up and running as quickly as possible. By considering cost, reliability, and support, you should be able to pick a cloud provider for your server. I would caution against just blindly going with the hyperscaler without doing a bit of research about what other options are available. Terraform is an infrastructure as code tool used to build, change, and version control resources. Terraform works with both cloud and local resources. In this section, we'll explore the concepts we need to understand to deploy our virtual server. First, let's jump in and talk about providers. In Terraform, providers are the code that runs behind the scenes, allowing your code to interact with an API. These providers allow us to send commands to services like Vultr or AWS to deploy our resources. Next, let's discuss resources. In Terraform, resources are what we use to describe the infrastructure we want to build. Virtual machines, virtual networks, and even DNS records can be described using resources to tell Terraform what to build. Finally, let's go over TF-vars. TF-vars are the variables we use with Terraform. They can be used to pass things you don't want hard-coded, whether that be because it's a secret or because it's something that is likely to change, and you'd rather not change your resource code. Using providers, resources, and TF-vars files, we will be able to define and deploy the virtual machine we would like to order. Finally, we're talking about the Terraform code. Let's look at the code that will give us our server. First, we have the provider file. In provider.tf, we are telling Terraform which providers we will be asking to use. On line number 3 through line number 6, you can see we're asking to use the Vultr provider with version 2.19.0. On line number 10, we're telling Terraform that the API key is for the Vultr provider, and on line number 14, we're instantiating the variable for Vultr API key, and on line number 15, we're instantiating the variable for SSH unique ID. Next, let's look at our resource file. This file is called vultrinstance.tf, and it has a resource block in it where we provide labels, tags, hostname, plan, region, operating system ID. We're enabling IPv6 and providing the SSH key unique ID for the key that we'll be using to log in. Finally, we're looking at the TF-vars file, which contains our variables. In this file, on line number 1 is where we would define the Vultr API key, and on line number 2 is where we define the list containing the SSH key unique IDs that we would like to access our virtual servers with. These variables could also be set as environment variables with the tf_var prefix. Now that we've gone over the basic concepts and have the code ready, let's run it. First, from our console, we will navigate to the directory that the Terraform code is located in. For me, that's projects, Minecraft, Terraform. Once in that directory, I will run terraform init. This will initialize Terraform, installing the providers that I need. Right here we can see that the Vultr provider has been installed with version 2.19.0. Once that's done, we can run terraform plan. This will give us a deployment plan showing what resources will be created. Here we can look through and see hostname, labels, plan, OS ID, everything that we defined in our resource. Then we can run terraform apply to apply the plan once we're satisfied with it. And we're prompted here to type yes to approve the plan. So we're going to do that. Then the instance is now being created. This process here can take about a minute. So we'll just have to kind of sit back and relax while we're waiting. Alright, once this part's done, we can type terraform show, and that will give us the information about the server that was just deployed. And if we search for main IP, that will show us the IPv4 and IPv6 addresses. The IPv4 is the one that we want, and we can just SSH into the host using SSH root at and then the IP address. And now we're in the server. Hopefully you enjoyed this tutorial walking through using Terraform to deploy a virtual server.